machine learning. Yeah, and we plan to cover some of the concepts that are there in machine learning. So this session is kind of like divided into 5 parts. We kickstart by discussing about some of the concepts in predictive modeling. Then we'll dive into the feature selection aspect as well as model evaluation, and then we'll discuss about productionizing machine learning models, which is a very core component which we do at industry level. And finally, we'll discuss a little bit about deep learning as well. So if you do have questions, feel free to unmute yourself and ask me, or you can pretty much ask on the chat. Yeah. Okay. So let's get started. So we'll start by discussing about some of the key concepts which are there in predictive modeling. So when it comes to businesses, right? So one of the key components that we get to identify or to do is that we have a problem, which in turn we need to convert it into a business problem, and through this business problem we need to give a solution, right? So without a business problem, there wouldn't be no use of machine learning, because I mean, it's machine learning. Yes, we can use it to as many of you would have taken part in Kaggle competitions or research level machine learning problems, but the core component of this machine learning, or the beauty of machine learning, lies in how we understand the business problem and translate into an analytics question, thereby answering the problem, right? So first of all, what we kind of do is through this machine learning use case or the analytics project, we try to understand what kind of problem that we need to solve, which in turn is a business problem, and we need to understand it. So some of the key things that we need to do is we will do some kind of data analysis to understand based on our data whether there are any kind of trends that are there, or if there is a particular problem which we need to solve, are there any reasons behind that problem, and then using a machine learning model or an advanced analytics solution, we would try to kind of model this into a machine learning solution, and thereby answer the business problem. And then there are a lot of machine learning techniques that are out there, and you kind of try to understand what is the suitable way of solving this problem. And so there's no right or wrong way, I would say. At the beginning, at the start, we would kind of like play around with the data to understand what could work. So, and one of the key things that you need to figure out from the start itself is what we try to solve right now. Just because there will be fancy machine learning algorithms that are out there, and even the fact that we have generative AI also there, so you could kind of like come up with a quick MVP or like a POC kind of solution, but you need to keep in mind what you plan to solve. So that would primarily be our response variable or y variable. So based on that, we would try to figure out, okay, what would be the best features that are out there in order to solve that problem, and then we would try to kind of come up with a machine learning solution to solve that. So one of the key things we need to do here is we need to understand our variables that are out there, and then kind of structure our mathematical or machine learning equation, which would be the modeling part. So it's very important that we understand what these variables are, and then we could kind of transform it to the analytics question that is out there. Right. So just to give an example, so I will like listed down some examples out of the mini which are there. For example, if you want to understand market trends, say for like a beverage manufacturer, we would have to figure out, okay, what would be the factors that would kind of make sense, that we would be able to figure out, okay, if the market share is high or market share is low. So we need to know what these variables are. And then if you take one of the, I would say, the common use cases of machine learning would be forecasting. And in particular demand forecasting. Let's say for a retailer, if you are going to forecast, say, sales in the next quarter or the next week, you would figure out what would be the most ideal features that would be essential in order to come up with the solution or be it optimization problem. This is really important. So we need to figure out, first of all, what we solve, and in order to solve that, what are the key variables in order to answer analytics questions. That's the first step that we need to do. So in this case, I've taken an example, right? Now, in the context of a supermarket, right? Assume that we want to forecast demand. So this is something that is, widely done through analytics. Given the advancements of analytics, is something that we usually do, right? Even if you take like a small shop, you would kind of, on the back of, even if analytics is not used, the shop owner would have a sense, okay, whether a particular item is getting sold more or less during the weekends, or during, whether it's raining or whether it's sunny, right? So this is something where intuition or analytics is used right now. For example, if you want to forecast something, in particular the demand of a particular item, we would need to have certain aspects. For example, if we are going to predict the demand for the next quarter, we would need to know, okay, what would be our X variables, right? So the sales of that particular item, and then if we have particular demand levels, we can categorize these demand levels, or other aspects like the customer buying patterns. So all of these elements would come into place, and then once you have these elements, we need to figure out what are the most suitable elements. Just because we have hundreds of elements, inputting all of these wouldn't give out a correct solution. So we need to figure out, okay, in order to predict or forecast the demand, what should be the most suitable feature. So this is something that we will be discussing in a little bit towards the end as well. So this is something that we need to figure out. We need to figure out what would be the correct variables that are out there. And in order to figure out these correct variables, there are a lot of techniques, feature selection techniques, certain dimension reduction techniques that are out there, and these features would also change based on what we try to predict. Now, if we are to forecast the demand for the next week, the features would be different compared to instance where we are going to forecast features for the next month or features for the next year, right? So depending on the granularity of the way that we prepare our data, how we chose our Y variable, our X variables, our features would change. So this is something that you need to keep in mind, right? Okay, so here there's like a very basic example. Now assume that you want to forecast the rent, right? And we have some features that are big, like distance, size, year, right? And there's another feature, right? So now if someone asks you, okay, what would be the rent if the distance was 0.5 kilometers, size was, say, particular value, year, say 2018, and the distance to the center, say 6 kilometers, right? So you would kind of probably look at the data and kind of come up with a guess, right? Which is what we usually do, right? So sometimes a lower distance would have probably a lower rate, I don't know, or maybe a higher rate. Looking at the pattern, we can come up with an individual answer, which might be correct or sometimes might not be correct as well. So this is where machine learning comes in place, because if we have one or two features, probably to the back of minds, or even in this case, since we have like very few number of features, we can come up with a solution or an answer. But the challenge comes when we have complex patterns, when we have a lot of features, a lot of data, right? Now, adding another 10, 15 features to this shouldn't be straightforward. So that's where machine learning techniques come in place. Now, for this example, so when the distance is 6.1 kilometers and the size is this particular value, then by using a machine learning algorithm, we can come up with a prediction or a forecast for the rain. Now, mind you, in order to choose the machine learning algorithm, there are a lot of algorithms that are out there. You can go with like a simple linear regression model, or you can even go with a more complex kind of a machine learning model. But in order to choose this machine learning model, there are a lot of steps that you need to follow. You need to make sure that you choose the right model for this particular data. Just by going with a complex machine learning model might not solve your problem. Sometimes even simpler models would so you need to be very mindful of the kind of machine learning model that you use based on the problem you need to solve. Because the tendency that we have is more complex or more advanced models would look good or would give you a very accurate answer, but that is not the case. All sometimes simple models like even a regression kind of a model might solve the problem. Okay. Right. So there are some. Okay. So just to make it a little bit interactive, probably you can ask the audience as well. So I have a question. So the question is: suppose we choose a machine learning model, right? So I assume that you all have some kind of a background knowledge about machine learning. The question is, will a model always perform the same on unseen data? So this is data that the model has not seen. So what do you think the answer is? Uh, is it yes or no? Someone like to unmute yourselves and answer. Doesn't matter if it's right or wrong, you can go for it. Any guesses? Or you can use the chat as well. Okay, right. So probably I can't see the chat because I'm sharing my screen. Okay, so it's like this. So we can't say yes to this because see models, they are more like you can think of as ways in which we recognize patterns, right? So depending on your data, right? So you can't always say that the model will always perform the same on unseen data, because if the data distribution changes, it won't. So here in this case, the answer would be no, right? But as yes. So the next question is, does a model truly learn the underlying relationship between inputs and the target variable? In other words, would a model truly learn the relationship between the dependent variable and the independent variable, or in other words, the x variables and the y variables? What do you think? Is it yes or no? So most of you might think yes, but however, the answer would be no, right? Yes, we may or may not have like a mathematical equation. However, models don't truly learn the underlying relationship, right? So what models are good at is capturing patterns or correlations, right? Even when it comes to AI models, right? NLP kind of models, it's even the models that are out there, right? GPT, if you have used Chat GPT or DeepSeek these days, so it's pretty much an expert a prediction, right? So based on a probability distribution, it will predict the most suitable word, right? So not that the model has truly learned the relationship, but because it's good at understanding patterns and then combining everything together. So here also it will be no. Then the next question: can a model predict values beyond historical range? In other words, can it extrapolate correctly? What do you think? So here there are three options: yes, no, and also there's a maybe. In this case, I would say yes and no both are correct, right? So so in that sense, the answer would be maybe, since we have a maybe, because there are certain machine learning models that can predict beyond the range, and at the same time, there are machine learning models that are not good at extrapolating or cannot give accurate predictions when it comes to extrapolating. Right? So depending on the machine learning model that you choose, your answer would be either an yes or no. Right? Right. So again, you'd be very careful when it comes to extrapolating, because you need to look at the underlying assumptions of the machine learning model before you choose to extrapolate, because there's a chance some model can overfit. So be very careful. This is something that we need to keep in mind. Right. Okay. Now, when it comes to feeding a machine learning model or solving an advanced analytics problem using machine learning, so there are some steps that we need to follow. So I have like listed down a set of steps that we follow. And actually there can be many more steps, but this is on a high level some of the steps that we need to follow. So the first step that we need to figure out is what kind of a problem are we solving, right? Now, this is one of the basic things that we need to understand, whether we are going to go with a regression kind of a machine learning model, or are we going with a classification model. Right? So this is the first thing that we need to figure out. So if we don't know this, there's no way that we can proceed, right? Because if it's like a quantity that we need to forecast, and if we try to solve it as a classification problem, then our approach is wrong. So we need to first of all figure out what kind of a machine learning problem are we solving, right? Then the next thing would be we need to know, okay, whether machine learning models work or not. Now, this is the evaluation comes in place. So we need to come up with the most appropriate, or we need to figure out what are the best evaluation techniques based on the machine learning model that we use, because there's a chance based on our data and based on the machine learning model and the underlying distribution which is out there, our data can overfit or underfit, right? So in that case, we need to sometimes tweak our machine learning model, right? Or even change the model or the entire approach, or even the features that are there. So this is where evaluation metrics come in place. So classification models, we have certain evaluation metrics, which we will discuss in a little bit, and also the regression kind of models also we have evaluation metrics, and using these evaluation metrics, we can get an idea, right? Whether we have chosen the correct machine learning model or we have the correct features in place. So once we do that, then something that we need to do is we need to split our data. So something that we commonly do is we kind of allocate a test set where we test a machine learning model, and also we have a training data set. And optionally, if you can, if you wish, you can have a validation data set as well, right? Which where the data has not even, where the model has not even pretty much seen that kind of data, right? So that is to figure out whether the model will generalize properly to the unseen data. So by doing this, we can fit our model. We can train our model using our training set, and then we can kind of get an idea regarding the error using our testing and validation data sets. And this is where the fine tuning of the model can be done by changing the features, by transforming the data, so on and so forth. So then once that is done, we can simultaneously do the model development and the model assessment. That is, we can try out multiple machine learning models. We can experiment with the features. We can exclude or include certain features, and then we can go back and forth testing the model performance. This is an iterative kind of step where it can take less time or even a lot of time, depending on the complexity of the problem that we solve, and also the machine learning models that you choose. And once that is done, we would be in a position to choose, okay, what is the best model to solve the particular problem, and then we can evaluate the model using the evaluation techniques and figure out, okay, are there any areas of improvement that is out there. So this is the entire step that we use when we try to train a machine learning model. Right. So since I spoke a little bit about the feature selection, so I'll here we'll discuss a little bit in detail about what are the prominent feature selection techniques that we use there when it comes to machine learning models. So now the first thing that we need to figure out is, okay, why do we do feature selection in the first place? Just for the sake of doing it, or is there any science behind, or in other words, is there any kind of method to this madness, right? So why do we do it? Right? Because you would probably hear a lot of folks do feature selection, right? So why can't we just train a model with the features that are out there? So if you would have heard this term called overfitting, that is one of the primary reasons why we do feature selection. Because a common misconception that is out there is, if we input a model with a lot of features, we would have a very high accuracy. Yes, we would see a high accuracy on our training data, but when it comes to testing data, or the data the model has not seen, that is where the problem comes in, right? So on this graph also, you could see, so usually you would have instances where you would have high bias and low variance, and also then you would have scenarios where you have high variance and low bias. So this is something that we kind of struggle a lot, right? So when it comes to overfitting, classic cases, we have high variation and low bias. So we need to come up with a somewhere in the middle ground, right, where we have enough somewhat moderate variance as well as the bias is somewhat low, because we don't want it to have very high variation as well, because that is a scenario where it can overfit. And one of the ways that we can kind of reduce this phenomena is by going on by trying on simpler models, right? If you can solve a particular problem using a simpler model, that is the best way to go forward. Because one thing, it's we wouldn't come up with overfitting. I mean, I'm not saying that we wouldn't, we can, but it will be less. And also it's easily interpretable. And also some of the one of the key issues that we face when it comes to enterprise level machine learning models is the cost, right? Because if our machine learning models incur high cost, right? Because the more features we have means the more data, right? The more columns, right? That means the volume increases. Hence, the cost also, storage cost, inference cost, or even training cost, all of these increase, right? So hence, it will be very costly, right? So that's why if I take an example from generative AI, why are small language models cheaper than large language models, right? So a model like GPT 4, which has like 1.75 trillion parameters, right? It's pretty expensive, right? Inferencing costs, right? Or even training costs. If you use the API, it's expensive. But a very small amount, with like 7 million parameters, right? They are much cheaper. That's because the less parameters or the less features which the model is trained on, the less computational cost it has impact. So you can provide the model at a cheaper price, right? So, and also it's very easy to optimize. So try to solve a problem first of all using a simple model. And if it is difficult to solve, or if you think, okay, the model is not good enough, you can try out everything that's there, then you can increase the complexity. Because sometimes that 1 or 2% accuracy gain in a model might not be cost effective, right? So because of that, you sometimes you wouldn't mind sacrificing that maybe 1 or 2% accuracy increment if there's a big cost reduction, right? So this is why simpler models would be the first step. Then step by step increase the complexity. Okay, so now when it comes to feature selection, so I think I kind of like I explained this in the previous slide as well. So feature selection is pretty much a set of techniques that are there in order to figure out what are the most important features to train a model. So there will be so many features that are out there, but we need to figure out what are the most important features. For example, if you are forecasting a demand for the next week for a particular item, we would have a feature like price of that item, right? So there can be like features that are there, the selling price as well as the cost of that items. Sometimes you would more often than not see a correlation between the selling price and the cost. In that case, you need not input both the selling price and the cost as a feature, because if both are like highly correlated, or in other words, they are like highly related to each other, you don't have to input both the features, because inputting both the features wouldn't guarantee or wouldn't make the model better, right? Sometimes, or like most times, it's best to go with one feature. This is where feature selection is very important. So it simplifies the model interpretation. So like I said, unnecessary variables we don't include, so the cost will also be less, and also the measures that we use in terms of accuracy will be much better, especially on the unseen data. Thereby the model will be able to generalize better, right? And we will have good results, right? So because of that, feature selection is a very important factor, or something that we need to make sure that we perform, right? Right. Now, when it comes to feature selection, there are numerous techniques, and I have like listed quite a few, like the F test, the chi-square test, like decision trees, mutual information. So there are multiple techniques, even like dimensional reduction, some of the dimensional reduction techniques like principal component analysis. So these are also part of the feature selection technique. So I won't go through each of these, because you would have used most of these, and or you would get to use most of these in your future projects or assignments. So keep in mind there are a lot of feature selection techniques that are out there, and you can uh, play around with these feature selection techniques based on your machine learning problem. So depending on your problem or what you try to solve, or your machine learning algorithms, your feature you need to use, keep in mind, right? And it's very easy, given that libraries are inbuilt. You just need to import these libraries and perform a feature selection task, right? So next important concept that we need to do is evaluate our machine learning models. Just because we have a machine learning model in place, we can successfully train a machine learning model, doesn't mean our model is always accurate. So it might look accurate, but sometimes it may not be accurate when we productionize a machine learning model. So model evaluation is a key component that we should uh, perform, right? Now, I stressed at the start as well. So there are a lot of machine learning model evaluation techniques, and based on the kind of machine learning model that we use, the evaluation technique would differ. Right now, if you go with the regression kind of a machine learning algorithm where you predict a quantity, right? So your machine learning evaluation techniques are also quantity based, or in other words, distance based, right? So something like an R square, right? Or mean squared error, root mean squared error, mean absolute deviation, MAPE, mean absolute percentage error. So these are some of the evaluation techniques which we use, and these evaluation techniques are distance based, right? So I won't go in detail about the equations. We probably would be like using them. So you need to make sure that you should always go with a quantity based or a distance based evaluation take criteria when you try to solve a regression kind of a problem. And also you can look at residual plots as well based on the distance between the actual values and the prediction, so you can get an idea whether your distribution is skewed or not. So then on the other hand, we have classification kind of problems. Now, in this case, what we essentially try to achieve is predict a class or predict a quality. Right? In regression, we predict a quantity, which is a numerical input, whereas in classification, we try to classify the class. For example, if it's a simple example, if it's gender, male or female, or if it's say, I don't know, color, blue or red, right? Say the two colors, right? So it's a class, right? So in this case, we can't go with quantitative metrics. So we need to go with qualitative metrics. So these are metrics such as accuracy, precision, recall, specificity, etc. So then we can come up with the contingency tables, right? Or we can even go with a little bit more advanced techniques like the ROC curve, where we check the true positive rate and the false positive rate, and then the AUC, which is derived from the ROC. So those kind of metrics we can go about. So based on these metrics, we can assess the suitability of the machine learning model applied on our data, right? And based on your data, your model would change. There's this saying, your model is as good as the data you have. So this is where these evaluation metrics come in place. Because certain evaluation metrics sometimes might give you a higher value, whereas another evaluation metric might give you a lower value. So just to give an example, say you're predicting, I'll take a regression example. Say you're predicting demand, right? Say demand, okay? Your example, say you want to predict the demand of carrots for next week, right? In a retail small shop, right? The value that you have is 1,200 demand. Okay, I'm not saying what it is, 1,200, right? So if you go with like a mean absolute error, your error is 20. Okay? So 1,200, 20, right? You would think, okay, 20 is not a big amount, so it's okay, right? But what if I said 1,200 is grams and 20 is kilograms, right? So in that case, if you convert it to the same scale, actually it's 1,200 versus 20,000, whereas the error is much higher, right? So now this is a classic example where you need to be mindful of the value you have. So in such a scenario, you can go with a metric like a mean absolute percentage error, right? Where it essentially gives you a percentage error, where okay, it's not just a quantity, it's a percent, right? But in a scenario where you're going with like a very sensitive measure, right? So even a small percentage, say you're testing a drug, right? So be very careful. But if you go with like a large measure, sometimes even like a large value might not be that impactful. So be very careful what kind of evaluation metric you use, and depending on your business problem, you need to assess the correct evaluation criteria. Right. So that was the example from regression, and also same applies for classification as well. So you can even be a binary classification, or it can even be multi-class classification where you have more than two classes. So you can come up with different evaluation criteria to figure out what works best, right? So sometimes an accuracy of 80% might not mean anything. You think, okay, accuracy is very high, but that might be a misleading uh, scenario. So that is a metric such as precision, recall, come in place. So we need to understand what works. So just to give an example, say in a say. A good example would be where there's class imbalance, right? So say you need to figure out you're a data scientist and you're working for a telco organization and you want to know or assess the customer churn, right? So in a classic telco scenario, the churn customers are like very low compared to the non-churn, right? So if you have like maybe 1,000 customers, probably one or two churn, and maybe 995 would not churn. Right? So it's like it's even less than 1% in most cases, unless something uh, drastic happens. It's very low, right? So inevitably, if you look at the accuracy is always high because the non-churn customers are high, right? So accuracy might not be a good measure, right? Because accuracy will always be 99%, right? Because of the non-churn customers. Those customers are anyhow there, but your objective is to figure out these one or two customers that actually churn. So that is the measures like precision, recall, come in place. So sometimes a high accuracy doesn't mean anything. So you need to come up with the most appropriate metric, evaluation metric. Right. So that is what I explained earlier. So it's the same thing on this slide. So the question is, model has 90% accuracy. How good is it? What do you think? Is it great, good? It should be higher than 90%, or does it mean anything? So it depends on the business context, right? Now, like I said, for like a telco scenario, yes, 90% might not be. It actually doesn't mean anything. And so you need to look at other metrics other than accuracy, right? Because accuracy is it only gives one side of the story, right? So especially when it comes to classification problems with imbalanced classes, you need to look into other metrics as well. Okay, so one of these metrics are the ROC curve. So you can pretty much check the true positive rate and the false positive rate, right? So here you have the 45-degree line, and if you can kind of like try to, if you can get like a ROC curve somewhere, a little bit higher towards this side and gradually like, reduction. This is where you can, figure out, okay, what's the like the appropriate setting. And based on that, you can come up with a cutoff value for your probability score, right? So we need to look into metrics that are that has more like meaning to your business problem other than just simply relying on accuracy, right? So this is one metric. Okay, and the next thing is when it comes to a high quality model, right? So there are multiple aspects that we look into. Right? So these aspects are beyond the usual accuracy that we check. Now, when it comes to evaluation metrics, uh, it gives us a number. It gives us a number whether for example, a model is 90% accurate. So that's it. Right? Other than that, we don't know. Right? So okay, it works 90% of the time. Someone can argue, right? But what about the other 10%? Right? So there are other aspects that are there as well, especially when it comes to enterprise level or industry kind of machine learning problems, right? So accuracy, I won't explain. You all probably you have lot of experience theoretically what accuracy means. Accuracy basically how accurate a model is, or how close the model is, how close the predictions are when it comes to the actual result. So that is something that is actually one thing, but there are a lot of other aspects that are out there. So one of those, some of those are precision, or whether your model is precise. Now, by precise, I mean whether your model is consistent. Right now, or the model can reproduce the same output over and over again, or time to time. Right. So, a good example to explain this is, so for example, now if you are repeating a machine learning experiment, right, and if you kind of like keep changing your settings slightly, right, whether your model is able to continuously give the same answer or the same output. Right? So there can be scenarios where your model is very accurate based on your evaluation, but your model cannot give consistent answers. So that in such scenarios, you need to rethink about your machine learning strategy. Right? Now, this is something that you would have come across a lot when it comes to AI tools, right? So yes, you would get an accurate answer, but your answer is not consistent. If you keep like changing certain aspects, your answer kind of changes, right? Now, the next thing would be robustness, right? Now, robustness means it's similar to being precise, but once you kind of change your parameters or the underlying conditions, whether a model is able to, keep the performance aspects intact. That is something that we check in robust. So, a model should be able to, keep its performance across, even if we change certain conditions. For example, say you have like a hyperparameter for a machine learning model. If you slightly adjust the hyperparameter, or if the settings change, and if your model output changes considerably 10x or 5x a lot, that means your model is not robust, right? So that is something that you need to be very careful, because we are more often than not we are unable to replicate the same hyperparameters or the same conditions. This is something, robustness is something that you need to be very mindful, especially when you're going with complex kind of machine learning models. And the next thing that comes is interpretability. Right? Now, your model might be very accurate, maybe 99.9%. Sometimes underlying you don't know what's going on. Right? We call it a black box. Right? Okay, you have this amazing, fantastic model which is so accurate, but it's not transparent, or you don't know what's happening. Right? So now that's something that is questionable. Yes, you get a high accurate answer, but you are not sure how the model works. So in such scenarios, it's not a good thing, right? Because more often than not, once you have a machine learning model in place, you might have to explain, right? Okay, your model predicts your sales. The sales is say 30 units. Right? So you train one of the most complex of deep learning algorithms, right? But you are unable to explain. Sometimes it's not a good thing, right? Because we might have to change certain criteria, but since you have trained a very complex model for a very simple problem, you are unable to interpret. So those kind of black box models might not be a good solution. So we need to be sometimes mindful of what the interpretable aspect as well, right? And then the most important, last but not the least, very important thing is a model should not have any bias. Right? Now this is determined on your feature set. Right? Now if you say you're training a model uh, uh, for a classification task, right? Say whether customer would churn. Okay, let me take another example since I took a churn example. Say you're a bank your data scientist is working for a financial institution and you want to figure out whether customer uh, would be a non-performing customer or a simple terms, whether customer would be a good customer or a bad customer. Good customers are customers that pay loans on time. Bad customers are customers that default. Right? You go and train your model on say graduates. Your data set has only graduates, meaning like educated people, right? With all due respect, right? So that is an unbiased model. It's a biased model. Sorry. So because your data set doesn't cover non-graduates, right? Because not all the people are graduates. So your model would be more biased towards that particular dimension of the population, right? Or especially when it comes to this ethnic criteria, your model might be sometimes biased towards, say, particular ethnicity, right? You train your model from data related to a particular ethnicity, right? So then your responses would be biased towards that ethnicity, right? So those kind of things also you need to be careful. Yes, your model would be accurate, but what if you get data from another gender or another ethnicity? Or if you go and train a model with all females, right, for a particular scenario, right, or information of all males, right? So you need to make sure your model is unbiased. Sometimes based on the data, it might not be possible as well, but there are certain techniques that you need to follow. For example, like criteria like oversampling, undersampling, those kind of criteria, you need to make sure that your data set is balanced, because if not, you would have a biased model. Something that you need to keep in mind. Accuracy is not the only thing. So all these factors combined would give you a high quality model. Okay, high quality doesn't mean highly accurate. It's also something you need to remember. Right. So coming back to what I said, because of this, a classic scenario that we face is overfitting and underfitting, right? So you would have all the fancy features in place, and the state of the art machine learning models. What would happen is your model would try to memorize instead of generalize. The model will try to try to remember the without like try to understand and identify the fact. It will try to remember. That is a classic scenario of overfitting. Right? So your model will work well on your training data, will have very good accuracy, but when it comes to unseen data, the model will be able to generalize. And the other scenario is underfitting, where your model anyhow doesn't work well with the test data. Sorry, your training data, and also definitely it won't work well with the test data. So these are the two extremes, right? And where you need to target is somewhere here, where your model has a right balance between the complexity and also generalization of the data the model has not seen before, right? So it performs pretty well on your training data, and also when the model is provided unseen data, that is also the model works in that scenario also. So that's where you need to target. So this is what a good machine learning model is, right? So high accurate doesn't mean your model is good. There can be a scenario of overfitting. So you need to ensure this setting is what you target. Right. So that is where criteria such as hyperparameter tuning comes in place. So I won't go in detail. So there are techniques like grid search, cross validation, then random search, Bayesian optimization. So these kind of techniques you can use in order to make sure that you provide the correct parameters, or you tune your model properly, especially when it comes to complex models, right? So a lot of boosting models, you need to make sure that you set your hyper parameters properly, right? So like the number of trees, the Gini index, those kind of measures you need to make sure that you provide it properly, because these are highly influential by the user, right? So if you don't tune the parameters properly, your model more often than not will overfit. So one of the techniques that we can use is grid search. For example, if you are going with a random forest model, your predictions will be determined on the hyperparameters you set, which is the number of trees, the variables per tree, the maximum depth of the tree. So if you set like a parameters like 100 trees and 66% variability and depth of tree, you are making the model restricted to this set of hyperparameters. So this is where you need to go with a grid search technique where you try all these combinations, all these permutations and combinations to figure out what is the best set of hyperparameters where your model generalizes to the data. Right? So just because a set of hyperparameters give you a high accuracy doesn't mean it's the best model. So you need to try out all possible combinations to come up with a well-optimized model. However, on the flip side, this can be computationally very costly. Now, in a let's say in a assignment kind of a setting, yes, you might have very small data sets, but in a production setting where you have millions of records, doing these kind of techniques will be a little bit less practical because of the costly involved. So you need to make sure even before you do this kind of techniques, you have a proper idea in place. Okay, what are the most optimal hyperparameters where you can then tune it, because you don't want to try all the combinations simply like a for loop and try all of these. Yes, you can even go for days. You can increase your clusters, complex compute, etc. But then again, you need to be careful about the cost aspect as well. Right? Okay, so another technique that you can use is cross-validation. So most common technique that we use is K-false cross-validation, where you take your training data, you break it. First of all, you split your data and you keep like a testing data because you don't want to keep the model on the entire data. Then your training data, you divide it to set of folds, right? Where we train and test the data on each fold. Right? So you keep one fold for testing and the other K-1 folds for training on a given particular time. And then you can, based on the iteration, say 6 times, K6, you can come up, you'll have the accuracies and then you can come up with a aggregation of this accuracy. Thereby, what will happen is your model will be trained multiple times and all the data will be used for training as well as evaluation on the training data set that you choose. This is another technique that you can use. So since you artificially increase your data set, the overfitting will be reduced. So this is another technique that you can use. Okay, right. So yeah. So coming back to this, when it comes to training machine learning models, especially in an enterprise level, so there are some other key factors that you need to keep in mind as well. Right now, one of the most important things is accuracy. So this you pretty much know, right? Based on the multiple checks that you do, right? So you would get an idea as to how accurate your model is, right? But accuracy alone, wouldn't work, right? So like I said, there are other aspects that you need to check. So another thing would be input sensitivity, right? Now, whether your model, yes, your model will be accurate, but based on your data or subsets, whether the accuracy would remain, right? Say you have a model to classification problem to determine whether customers would churn or not, right? So whether your model perform across different population subsets, that means will it work for customers above 60 years old? Is it the same accuracy for customers between 50 to 60? Or customers who are teenagers, or customers in a particular gender, or customers in a particular spending category, right? Does it work across these brackets? That's where input sensitivity comes in. So yes, we have like a holistic idea that accuracy is X%, but does the X% replicate across these different aspects of your data is something that we need to also check, right? And the other one would be flexibility. So flexibility means, is a model able to adapt to new data? What does this mean? For example, let's say your model is working pretty well, right? However, all of a sudden, your data landscape changes. Classic example would be something like COVID, right? Then customer buying patterns change, panic buying happens. Sometimes there are set, data for training a model. There will be scenarios where you don't have any transactions happening. So is your model flexible enough? Can your model handle those kind of scenarios? So that is something that you need to kind of think through, right? Yes, smooth in a very normal situation, your model would be working well, but will the model adapt to different settings? That is something that you need to also test out, right? And then we spoke already interpretability, right? So can your model be interpreted, right? Sometimes just because you have like a high accuracy doesn't mean it's the correct modeling strategy. So you need to think about this as well, right? And then another thing would be the underlying process. Okay, so this is a very less thought scenario. Right? Now, so to give an example, say you're forecasting. You have a forecasting model, and you're forecasting in a retail scenario. You're forecasting. Forecasting can be done for different items. Say you're forecasting for items with long expiry dates, right? Like dry kind of items, like salmon tins, etc. Right? So you would sometimes want to over forecast. What do I mean by that? Because by over forecasting, you make sure if you forecast 50 salmon tins the next week, sometimes you might want to forecast 60 or 70, like a higher value, because you don't want to get into a situation where your supermarket or your shop would go out of stock, right? Because these items don't expire and the storage costs might be very less. So you sometimes intentionally forecast higher. Whereas there can be another scenario where you have short expiry items like vegetables or fish or meat items, right? You wouldn't want to over forecast. You would rather do under forecast because storage cost or wastage cost, in other words, of these items are much higher than the sales. Sometimes, like a kilo of, I don't know, like some particular poultry meat item can be like 2,000 rupees. So wastage can be like 10 kilos. You might lose 20,000 a day, right? So if you do the ROI, that's much higher than the return that you get or the profit, right? So you would want to be on the safe side. You wouldn't mind the meat or seafood get sold by 6 p.m. or 7 p.m. You go to supermarkets, you would sometimes see after 7 or 8 p.m. you don't have meat items or veggies, right? So you probably go during the daytime. So that is because they tend to under forecast those kind of items. So based on the underlying process, your forecasting approach should also change, right? Because that is something that you need to keep in mind. Another thing would be implementation. Okay, so you have a machine learning model. How do you implement this or advanced analytics solution across your business, right? So how will like what kind of steps you need to follow? So these are things that go far beyond your theories that you know learn or implement when it comes to machine learning. So you need to think from an organization point of view. Okay, if you launch this particular model, will the if it's like say a chatbot, right? It's actually something like that. Whether the organization would be able to embrace it or accept it. So if it quite to work, what kind of changes that you need or what kind of steps that you need to follow for it to work, maybe training or like employees how to use it. So those kind of stuff also you need to think. This is where this is mostly into the business side of things, but these are also important for your solution to work. Then another thing would be scalability. Can you once you uh, provide a machine or you productionize a machine learning model, can you scale up as well as scale down? So if you are not able to scale it up or scale it down uh, as you wish, that is also a bit of a hazard. So you need to make sure your model can be scaled up as well as scaled down as required. And then another thing would be integration, whether your particular model can be integrated into the existing workflows that are there on your organization, or you need to change or adopt new processes for your advanced analytics solution to work. This is also something that you need to make sure, because if your model is such that we need to change the entire business process, that is also something that might not work. So you need to be very careful how you integrate it, and sometimes you might have to integrate it step by step. Right? Right. And the next important topic that we'll discuss is uh, how do we productionize our models. Now we have machine learning. We know all about training machine learning models, how to develop accurate models. But the most a challenge that we face is most of these models don't work well once we productionize or we put it out to work, right, in an actual business context. So this is something that we struggle. So how do we productionize and also maintain our machine learning models? This is a very important topic. Now, when it comes to migrating our models, we have multiple environments. So in a common scenario, environment is pretty much like a system for the model to run. In a common scenario, we have like three main environments. One is a development environment where we test and develop a machine learning model. And then we have a QA environment where we kind of assess the quality of the model. And also once we productionize, we have a live environment where we don't touch the model. Pretty much we don't change the model. That is the working final level model, right? Where we use the model with the predictions of the model are used to address business scenario, right? So now, depending on the organization, these environments can change. There can be organizations where you don't have a QA environment, where QA part is done in the dev environment and straight away migrated to the production environment. So this criteria is called deployment, where we have a model in the development environment, then we develop the model, and then we do lot of testing and ensure that the model has obtained satisfactory level quality, and that is when we move our model to production. So this entire process is called deployment, and this is a structured tested approach where we ensure that our model will be reliable when it comes to actual usage. This is the entire end-to-end deployment process. Now, when it comes to deployment process, you'd have heard about CI/CD pipeline. So you can kind of break your this into like main steps. Initially, we kind of train the model, then packaging, validate, deploy, so on. Right. So here at the initial stages, what we do is we develop our model, right? So we gather the business requirements, we do all the data preparation, testing, and then finally, before we move it, what we do is we follow a particular process. Right? We don't just create like a bigger file and then we move it. But there's more to it. Right? So there are processes that are there in a certain depending on the organization, the processes would change, right? So there are standards, coding standards that you use. There are best practices that we use based on the team, right? So those kind of practices you need to follow, right? So mostly or generally, what we do is we package our model. So most common in our language that we use is Python. So you can package or create like artifact of the model, and then what we do is we validate our model thoroughly. That's where the QA part comes in, where we test, we do stress testing, we give models a lot of data, we do this kind of integration testing. So we need to make sure this model will integrate properly, and we run these kind of unit tests, right, to find that there are edge cases where the model would fail or not. So all of this testing would happen in the QA phase. Now, once this testing is successfully done, and you're sure that model is working, that's when you productionalize a model. However, even if you productionalize a model, depending on the setting, you might have to sometimes retrain your model as well. Right? If the environment or the factors change, you might have to go back and perform these steps one by one again from the start. So this is the entire CI/CD process, which is why we call it continuous integration and continuous deployment. So this like a pattern keeps on happening in a production setting. So when it comes to non-production environments, what we do is we just train a model, test it, that's it. But in production setting, software engineering best practices are also maintained. Right? Now, when it comes to deploying model, there are multiple ways, and the three common ways are one is like batch inference, where we have like a set of data that comes as a batch. It can be daily data or the data depending on the granularity, and then we will train our model and the data might go to a dashboard kind of a thing. Then we might have a model as an API. We can host it in a particular server as a REST API, and then we can pass that data, and then the model will give an answer. I think you would have heard about APIs a lot, given the fact that you use these AI kind of models. So not only AI models, non-AI models like the traditional machine learning models also you can host as an API, right? So through the API, you would have like a format. You can create like a Docker object, and then you can pass it into the API, and the model will give out a response. And then the other technique is real-time inference. Sometimes you might have streaming data, right? Where you would have these IoT devices. A classic example would be, let's say you have a greenhouse where you want to predict, say, diseases, right? So real time you would get measures like humidity, temperature, soil temperature, right? Rainfall, etc. And you would give like a probability, okay, what would be the, say, for this particular disease or the fungus to grow. So those are where real-time settings come in place. You can't have batch inference. You can't collect the data like hourly or daily and send it the next day. By that time, it'll be too late. So that's where real-time inferencing happens. So depending on this context, your deployment approaches would change, right? So these are, like I said, the key activities when it comes to productionizing models. So you first of all you create a deployment, like I said before, and then you evaluate whether your model is performing well, accuracy, consistency, etc. And then something additional you need to do is monitoring. Now, this is a very important factor when it comes to productionalizing, because your model might work very well, be very accurate, but sometimes after some time, after 3 months or 6 months, or maybe after weeks, all of a sudden the accuracy would start to dip. So this is where monitoring comes in place. So you need to have these dashboards in place, certain brief tracking mechanisms like population stability index, variable stability index. Those kind of measures should be kept in place in order to understand whether your model is drifting. More often than not, that is not because of the model, that is because of the data. If the data setting changes your model, you might have to frequently retrain, which is why I explain here as well. So you might have to retrain the data, retrain the model because of the data. So that's the same. A model is good as the data. Right? Sometimes the data might change, the environments might change, so you might have to monitor and retrain, and then this is where the management comes in. Like I said, you have to retrain, update or change your machine learning model. So this is a continuous process that we follow in the production environment, right? So yeah, so next I'll move in. So we have another topic that is to give you all an introduction into some of the deep learning concepts that are out there. So this is a bit of an independent topic. It's not related to the initial four topics that we discussed, but nevertheless, let's discuss. So to start off, you would have heard or you would have used image generation tools, right? So here there are three images that are out there. So which of these images do you think of it? Can can someone tell? Is it the middle image, the left image, or the right image? What do you think? What do you think these are real? So actually, all these three images are AI generated, right? So some of these images, when you look at the facial expression, so you might be able to kind of gauge, okay, this is AI generated, but all of these are actually AI generated images, using AI generative tools. Right? So you would have probably used DALI, Image Journey, right? So these kind of tools can be used to generate these images. So image generation has improved a lot, given that we that the latest advancements of AI. Right? Okay, now forget about AI. So let's discuss the I would say the building blocks, right? Right. So now everyone talks about AI, and there's actually a lot of hype about AI, right? Whether we like it or not. But where does AI start? Or what is the grassroots of artificial intelligence, right? So that is neural networks. So from uh, neural networks only, we have all these breakthroughs that are out there. Right? So with the 2019 attention is the all unique paper, that's when transformers was proposed by Google. So that's where this huge breakthrough of AI advancement started to happen. But prior to 2019, for 1920s onwards, neural networks have been there, right? Ever since the time people like Jan LeCun, Jeffrey Hinton, they came up with this concepts like AlexNet, CNN architecture. So neural networks have been there. So the only reason or the primary reason that they kind of like blew up was the fact that the compute power, as well as better algorithms, right? GPUs were there. So that's when it's kind of like proportion, but neural networks have been there. So this is like a computational approach that was inspired by how humans think, or in other words, how neurons of our brain works. So basically, our brain is smart enough to understand patterns, and based on these patterns, come up with prediction, right? Predictions based on how this learning adaptability works. Uh, we have developed this concept of neural network, where we basically mimic how our human brain works, and based on that, we try to understand patterns. We artificially use computer systems to understand actually evaluate existing patterns and come up with understand a particular pattern and come up with a solution. That is basically what we do using neural networks. So there are different types of neural networks. So you have neural networks that are used in NLP kind of applications, and also you have neural networks when it comes to image recognition, video generation, audio generation, all of that. Neural networks. Even when it comes to forecasting algorithms, you can go with neural networks as well. But remember, they are black box, right? So you more often than not, it is very difficult to interpret how a neural network works, right? So that's why neural networks are mostly used for pattern recognition applications when it comes to understanding complex patterns, because there are a lot of mathematical equations behind a neural network, right? So it's very difficult, I wouldn't say impossible, but very difficult to interpret uh, neural networks, right? Okay, now just to give an idea of how neural networks work. So like I said, neural networks uh, were developed looking at how the human brain uh, works, right? So in our brains we have this neurons, right, which are connected by the synapses. So basically what happens is our brain is able to figure out a particular input that's there, and then process uh, this by adjusting the synapses, and then come up with a decision. That is the entire decision making process, right? So when we hear certain things, when we see certain things, or when we even taste certain things, all of a sudden we would kind of, your brain will pass a signal, right? Now, for example, if you touch something that's warm, your brain is able to figure that out and pass a particular sensor back to your hand. Okay, it's warm, you should take your hand off. That happens instantaneously. That is the power of neurons, right? Now, what neural or artificial neural networks, I'll use the term neural networks, it's for artificial. What it tries to do, it tries to mimic how the biological neural networks work. So there also we have these connections, and then based on how the biological neural networks works, we would also pass in data. There will be layers, such as we'll have like input layer where we receive the data, and then there will be another layer where all the mathematical transformations will happen, and then you will have a final output layer where we would get the outcomes. That is how the entire neural network would work. So these neural networks are really good at pattern recognition, be it understand how text pattern works, or how like how to understand patterns in an image, or even like a video or an audio signal. It works really well because the traditional machine learning algorithms are not that smart enough to tackle those kind of problems, right? So distance-based algorithms, regression classification algorithms are unable to, solve these kind of problems. That is where artificial neural networks come in place. Now, the basic of the neural network is this perceptron. So we call it a perceptron, which is an artificial neuron. So basically, what happens is you have this mathematical equation where we try to mimic this representation of a actual neuron. Right now, what happens is when it comes to neural network, we have mainly three layers. We have input layer, we have hidden layer, and we have output layer. So input layer is where we basically pass the data. Hidden layer, there can be one or multiple hidden layers. So that is where we have the mathematical equations. You can have these different kinds of activation functions like ReLU, leaky ReLU, softmax, those kind of activation functions. What they do is they capture our input data and they will add some biases, right? And then through a transformation, linear or non-linear transformation, we would all these like layers, multiple, if there are multiple layers, they will do these mathematical transformations, and then to the output layer, this transformation outputs would come in place. That will be your final answers. That is on a high level how neural networks works. Now, based on your activation function or based on how your hidden layers work, your neural network will give out different answers, right? So that is where you can adjust your neural network in order to, or train your neural network in order to come up with an answer that you want, that you try to ensure that is as close as possible to your actual. For example, say you want to do a text summarization, right? So you would have like a baseline answer that you have, and then you can train your NLP application so that your output is as close as possible to your actual answer. So how you do that is you can train the weights as well as biases, as well as change your activation function so that it becomes as close as possible. Now, an advanced way of doing this is using much more complex techniques like transforms, right? There it goes beyond the realms of recurrent neural networks, right? If you take recurrent neural networks, they are like unidirectional. But if you take transformer kind of architecture, they are bidirectional, right? So that is those kind of techniques like the GPTs that you use now are the basics or the basis of these are neural networks. So more advanced versions is what that you are using nowadays, right? But the building blocks of this is what neural networks are all about, right? So, like I said, in a neural network, we have three layers. So we have the input layer where we input the data, and then you can have multiple hidden layers, and that is all the mathematical equations come in place, right? We process the data and transform the data, and finally through an output layer, you get an outcome. So this is the entire process of how a neural network works. And you can have different kinds of neural networks. So you can have this single layer neural network where you have like an input layer and only an output layer. You don't even have a hidden layer, which is a very simple version of a neural network. Then you can have like a multi-layer network where you will have input layer and output layer and also a hidden layer. And then you can even have this recurrent kind of neural networks where it kind of goes back and forth with the input layers as well as the output layer, where you have like a multi-directional flow, right? So based on that, you can tune your neural network so that you can get a very accurate response depending on the problem at hand. So, and also you need to make sure that you try out different kinds of neural network architectures for the problem, because for a particular problem, a particular kind of neural network might work, but once the setting changes, you might have to change your neural network as well. And mind you, computation cost is very high, especially when it comes to using training these neural networks, right? So if you have like a lot of data, uh, 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 you might have to have a lot of compute involved as well. So cost is also something that you need to keep in mind. Now, when it comes to neural networks, like I said, there are strengths as well as challenges that are out there. So uh, the the obvious strength when it comes to neural networks is that it's very flexible, right? So you can provide unlimited number of inputs, and based on how you have trained your neural network, you would inevitably get a very good answers. And the other advantage that neural networks have is you don't have to kind of do a lot of pre-processing like you do in traditional machine learning, because it is able to work well with factors like correlation, right, and missing values, etc., right. And based on the distribution of your data, you don't have to have assumptions. If you take a traditional regression kind of algorithm to fit the model, you need to make sure your data follows these assumptions. But neural networks, that is not the case. You don't have strict assumptions, and even complex kind of relationships can be modeled. However, there are challenges uh, involved as well. So, like I said, uh, neural network wouldn't always guarantee an optimal solution, because sometimes a neural network might not converge. It can diverge back and forth, right? And also, you need to have a good understanding about the problem that is in hand, and also a good background, especially when it comes to the mathematical concepts behind, right? And also, your neural network would depend on the quality of your data as well, right? If you uh, give low quality data, you wouldn't get a high quality input. So you need to make sure that you provide the appropriate data when it comes to training your neural network models. These are some of the challenges that you would face. So make sure when you train your neural networks that you keep a count of these as well. Yeah. I think this brings to the end of our presentation. So probably we can spend some time answering some of the questions that you had. Yeah. So yeah, so that's from my side. So do you all have any questions? So if so, we can take it up. Maybe the organizers can probably help out if there are any questions that are there on the chat. Anyone has any questions?
Yes, if you have any questions, feel free to submit them onto the meeting chat or use the Padlet link. We have some feedback on the chat saying, thanks for explaining the concepts simply, understood them well. And that's all for now. If anybody has any questions to ask Mr. Anuk Dissanayake, feel free to drop them in the chat box. There is one question. How can we get placed as an AI engineer? Can you give some career based advice?
Right. Okay. So actually, that's actually a very valid question, right? Now, uh, if you take AI engineer, right now, uh, it it depends based on the organization. Right now, if you take a particular organization A, the skills that are out there would drastically be different to organization B. That's one thing. So you need to kind of like understand what kind of technology that is out there. So I would say the key things would be, especially for AI engineering, you need to have this mindset where you have to kind of, be willing to adapt, right? Because, see, for example, if you check the AI space, pre-training was a big thing 6 months ago, but now pre-training is not a big thing. It's mostly about model distillation, right? Especially with the DeepSeek research paper that came out like in December, right? So things would change, and you need to have this mindset of innovativeness, right? And then also another thing would be you need to have a solid understanding about software engineering programming concepts. Statistics is very important, right? So that's where you have like a solid understanding about mathematics, like calculus, linear algebra, and also statistics. So theoretical understanding is very important, and also I would say like a mindset where you are willing to learn new things, right? Because this area you need to constantly adapt yourself. So that is those are like the main things that you need to have. Yeah.
All right, we have another question. Are there any specific interfaces or tools to develop ML models?
What do you mean by L model? Sorry, I didn't quite get you.
They're asking if there are any specific interfaces or tools to develop machine learning models.
Oh, machine learning one. Sorry, sorry. So interfaces, by interfaces you mean like software applications, right? So primarily machine learning models these days are developed, I would say, 99% of the time using Python. So you can use like any Python IDE. So for example, like IDEs like VS Code, which is like widely used, or you can even so if you are developing like a production grade machine learning model, I wouldn't recommend going with like a notebook kind of environment, because like testing purposes you can go with like a notebook kind of environment like Colab or Jupyter notebooks. But if you are like going for like a production base, make sure keeping what I explained earlier, right? Because we have to like create package machine learning model. It will be easier if you go with how you can like create your machine learning model as an artifact. Yeah, you can easily productionalize, right? So try to create Python packages. You can inference them as APIs, right? So yeah.
Okay, the next question we have um, is there an accurate concern on machine learning? How can we guarantee by using models on systems that require the most accurate vulnerable decisions?
Uh, okay. Accurate concern and how can we guarantee? The question is a little bit unclear, so just correct me if I'm wrong. So my understanding is that you want to make sure that what the model that you use is accurate, right? So probably that's what you mean by that question. So like I explained earlier, your machine learning model, you need to tailor it according to your data. Right now, if you have like if your business problem is to kind of like solve something very simple, right? So try to go out with a very simple model, right? And check, okay, whether your model is accurate or not, right? Whether it gives the right answer. However, if you feel okay, it doesn't work well, then try to increase the complexity slowly, right? A general like misconception what we have is we would try to kind of go with a very complex model, and more often than not, we would have high accuracy, but we don't know what's happening behind the scenes. If we have to change or tune the model, it will be very difficult. So try to start with a simple model and then try to increase the complexity. So that will be the best way.
All right, next one. I'm into creating products and models, like producing solutions. What is the role that would be suitable for me, and what do I have to focus to grow in that field?
Right. So that's actually, so it depends on what you want, right? Now, so there are a lot of roles. Okay. So even like you can even be a data engineer and still create products. You can be a data scientist and also create products. You can even be an engineer or even a software engineer, right? So if you are to focus, I mean, just if you want to like simply like grow in that field, I would say the best advice that I would give is you need to have this mindset of innovation. So you need to sometimes think out of the box, and also try to like okay, if I take an example from what's happening nowadays, a classic example would be something like Perplexity, right? So you have all these companies that try to train machine learning models from scratch, but company like Perplexity, what they try to do is they try to come up with an engine where it is able to use multiple models that are out there to give us solution. So like you have to like think out of the box, right? So that quality is something that you need to have. So and what you need to focus also depends on the time, right? Now, if you are very bullish about something now, but maybe in 6 months' time, that might be completely different when a new innovation comes in. So you need to be very adaptable, and you have to be willing to change or learn new things and also unlearn certain things as well with time. That is something that you need to focus on. Yeah.
Which programming language is the most suitable for machine learning projects, R or Python?
It's a hands down, it'll be Python as of now, especially if you are going with machine learning projects in production settings. Python, it's much easier.
All right, then we have this question. What range of theoretical knowledge and practical projects need to have as a recent graduate when applying for a machine learning, AI, or data science position?
Right. So that's actually a very good question. So practical projects. So in terms of domains, what you can do is that you can pick a particular domain, right, which you like, and then what you can do is you can so there are a lot of GitHub repos that are out there in public, so you can kind of maybe clone a particular repo and probably understand what's been done, and then try to develop something on top of that, right? Maybe you can start building from scratch, and then probably what you can do is you can maybe pick up pain point in the business setting and then try to solve it, right? And then when you try to solve it, try to think of solving like productionalizing, because like now if you take the data science role, like 10 years ago it was all about statistics, right? Then there was like computer science aspect that came with it. Now how where the industry is going is all about creating products, right, or building, right? And there are like two types of data scientists also. So one type is mostly into consultation, right, where you try to consult and give like a solution, right? So that is one. But that type of data science is a little bit less these days, because most of the I would say like majority of the roles are structured towards where we develop products. So there, what you can kind of do is you might have to improve your knowledge on Python programming knowledge, right? So those areas are also equally important. So focus on those sides as well.
All right, one last question. How do we determine the best number of neurons and layers for a hidden layer for optimum predictive capability in neural networks?
Right. So again, so this determines on the neural network architecture that is out there. Right? Now, if you, let's say you go out with an RNN, right? So one conception that you might have is having a lot of hidden layers would give like a more accurate answer, right? But that may not be the case. And also you can try out, let's say you have one hidden layer. In that hidden layer you can have like more neurons in. And also you can try out like another scenario where you can have more hidden layers, and within these hidden layers you can have less neurons. And also another thing that you can try out is you can play around with the activation function as well. So depending on the activation function, the kind of like neurons that are there would also change. So try like a combination of all of these. So change the activation function, try out the different layers, and also the number of neurons that are there on each layer. So try with all of these so that you can kind of, and also then you can check the predictive power as well, and then you can determine what works best for the setting. And it's very difficult to also give an answer without like checking how the data distribution also changes based on the problem. So I would say try as much as possible with these variations where you can get a good accuracy.
Okay, we have two more questions. One is approximately how much time will it take to train a predictive AI model?
Okay, predictive AI model means like a large language. So I'm assuming
It's
like see
predictive
AI.
machine learning model. Yeah.
Okay, machine learning model. Okay, so okay. So that's a very difficult question to answer. So it depends on your data, right? So I mean, if you have very small amount of data, right? So say like thousands of records, probably you can, and also your capability. So if you can write the code and you can do all the testing, probably you can even do within a few hours. Right? But if you have like a actual business problem where you need to solve certain things through multiple rounds of testing, it can even be months, right? There are some settings take a lot of time, right? So you have to go back and forth. So it depends on the complexity, right? What you try to solve. So it can be a few hours, or it can even be even months, right? So yeah.
All right, very last one. What are the tasks that we can do with machine learning models, such as natural language processing, finding spam emails?
What are the so what are the, can you please repeat the question? So
Yeah,
there are I think two questions, right? So one is you want to know the tasks that you can
that
do with NLP, and also another thing
with
spam email.
machine learning models, such as natural language processing. That's what it says.
Okay.
Yeah.
Okay, so I guess spam filtering was an example that you gave, right? Such as okay, so a lot of things. So you can use a text summarization, that is like a common use case that is out there when it comes to natural language processing. Then you can use it for text generation, right? So that's when you use chatbots that are out there. So you can use chatbots for customer service agents. Then also another thing. When it comes to this in a more advanced version of using NLP application is incorporating these agentic capabilities that are out there. So you can create more advanced NLP applications, and also another use case would be translation kind of use cases where you want to translate back and forth between languages. So there are multiple such use cases that you can use NLP applications for.
All right, that would be the end of Q&A session. Thank you so much for answering all these questions. Yeah, so that was an incredibly insightful session. A heartfelt thank you to you, Mr. Anuk Dissanayake, for sharing your expertise and valuable insights with us today. Your time, knowledge, and passion for this field truly made a difference, and we deeply appreciate you in your generosity in guiding us through this valuable session. Thank you so much once again. Now, before we wrap up, let's capture this moment. I'd like to have you all on your cameras for a moment for a quick group photo. You can download the virtual background from our WhatsApp group as well. All right. I think that's enough time to switch on the camera. So let's capture this moment on count to 1, 2, 3. 1, 2, 3. All right. Thank you so much, everyone. With that, we conclude today's session. Thank you so much for being a part of today's workshop. Thank you so much for our speaker, and thank you all the participants for the amazing questions that were asked, for interacting with the speaker and involving throughout the session for these 2 hours. A quick reminder that our second workshop is coming up on February 22nd, so stay tuned, and we hope you're gearing up for our hackathon that will be happening on 8th of March as well. You can use this QR code to join the WhatsApp group if you haven't yet. And let's wrap up for today with that. Good night, everyone, and thank you so much for joining.